We are going to look over your answers for the Logic of Quadrilaterals challenge on page 228 in your Bridges book. Number 1, it says label each shape in this diagram with the name that describes it most exactly. So if you take a look at this bigger shape that is 4 sides, and it kind of incorporates all the rest of the sides, this is going to be the first one we are going to label. And we are going to label that a quadrilateral because it has 4 sides. Whoops. With no particular angles or side lengths. So 4 sides, 4 angles, that's going to be a quadrilateral. Next, I'm going to take a look at the shape down here. And the shape down here looks a little odd also, but I'm noticing that this line and this bottom line are parallel, and since it only has one set of parallel sides, we're going to name this one the trapezoid. And there's no other shapes that are inside a trapezoid. Everything else is up here. So this shape right here, I'm noticing that the top and the bottom are parallel, but I'm also noticing that the two sides are parallel. I'm noticing that the angles opposite each other are congruent. And since that's all happening, we're going to name this a parallelogram. And inside a parallelogram, you can see this shape. It's got 2 sides that are congruent on the top and the bottom, and then the left and the right, but it also has 4 right angles. And since only 2 sides are congruent, that's called a rectangle. And inside the rectangle, you see another shape with 4 congruent sides with 4 right angles, and that one is the square. Over here on its own, you've got this shape. It's got 2 sets of parallel sides. You see opposite angles are congruent. They're the same. And since it's got 2 sets of parallel sides, this is a rhombus. And inside a rhombus, we've got this special shape right here. It's got 4 congruent sides like a rhombus, but now it also has 4 right angles. And since it's got 4 right angles and 4 congruent sides, it is a square. So you notice that all of the shapes inside the quadrilateral are quadrilaterals, and then all the shapes inside the parallelogram are all parallelograms also. Inside the rhombus, a square is also a rhombus, and then inside the rectangle, a square is also a rectangle. So question number 2 asks, why is the trapezoid inside the quadrilateral but outside the parallelogram? And the trapezoid is a quadrilateral because it has 4 sides, but it is not a parallelogram because it only has one set of parallel sides. And to be a parallelogram, you have to have 2 sets of parallel sides. So I'm going to say, and I don't know why my spacebar does not work when I try to type out words, but I will read it as I write the answer. A trapezoid is a quadrilateral, but not a parallelogram. And that is why it's inside the quadrilateral but outside the parallelogram. Number 3, why are there a rhombus and a rectangle inside the parallelogram? A rhombus and a rectangle are both types of parallelograms. Because they have 2 sets of parallel lines. I feel like I'm hashtagging without any spaces in between my words. Hopefully you understand that. So a rhombus and a rectangle are inside the parallelogram because they both have 2 sets of parallel lines. Number 4, why are there 2 squares, one inside the rhombus and one inside the rectangle? Well, that's because a square is a rhombus, but it's a special rhombus because it has 4 right angles. But a square is also, oops, a rectangle, but it's a special rectangle because it has 4 congruent sides. And that's why a square is both inside a rhombus and a rectangle. Number 5 says write at least 2 other observations to explain why the shapes in this diagram have been placed where they are in relation to each other. Well, we could say a number of things. All the shapes have 4 sides. We could also say all the shapes have at least one set of parallel sides. We could also say all the shapes inside the parallelogram have 2 sets of parallel sides. I'm going to go down here. Anything consistent with those will work. And go ahead, flip to page 230, Properties of Parallelograms. We've got some diagrams. We've got a diagram of parallelograms and a diagram of not parallelograms. So if you take a look at those and compare the two, we're going to list some properties of a parallelogram. So we just have to list 3. Some things that you could say are the parallelograms have 2 sets of parallel sides. Something else you could say would be they have 4 straight lines. Something else you could say is they're all closed shapes. The parallelograms all are closed shapes. It says to only list 3, but maybe you said they have 4 angles, because you can notice it. Oh my goodness, I can't spell. In the non-parallelograms, some of them only have 3 or no angles at all, and all of those have 4 angles, and then they also have 4 sides. So any 3 of those that you wrote for number 1 would work. Number 2, fill in the bubbles besides the other names that fit all parallelograms. And so you could have filled in quadrilateral, and you could have filled in polygon. And number 3 says add one shape to the diagram at the top of the page. So one shape I could add over here would be a square. Let's see if I can. And I'm trying to get my lines as straight as possible. I need 4 congruent sides. So that's my best bet at a square. And then over here on this side, I could draw a kite, because a kite does not have 2 sets of parallel sides. It only has 2 sets of congruent sides that touch. And there is my kite. Number 4, why can't trapezoids be classified as parallelograms? Well, we talked back on page 228 about a trapezoid. A trapezoid only has 1 set of parallel sides, and a parallelogram has to have 2 sets of parallel sides. So a trapezoid has only 1 set of parallel sides. A parallelogram must have 2 sets of parallel sides. And then last but not least, number 5, just circle true or false. If the opposite sides on a parallelogram are parallel and congruent, then the rectangles are parallelograms, and that answer is true. If a rectangle has four right angles, then all parallelograms must be rectangles. The answer is false. And then C, if parallelograms have four sides, then all quadrilaterals must be parallelograms. That is false. All right, save your answers for the homework quiz on Friday.